Welcome to Is454. I'm Professor Fahmi Jelani, for your lecture 2. Today we talk about ETL, extract, transform, and load. So technically, what you need to know, what is data warehouse, why they are necessary, and why is it constructed. Yeah. For data warehouse, technically it's subject uh, oriented. It's a physical repository where relational data are specially organized to provide wide enterprise-wide clean data in a standard form. Okay, in this case, subject-oriented. We have customers, patient, example, students, and product. Integrated, usually consistent naming of convention format, encoding structure from multiple data source, time variant, you can study the trend and changes. Non-updatable is basically technically a read-only file, periodically refreshed. Okay. Why they necessary is a centralized repository that are scattered through the system in order to make decision. Okay. Also, they are subject oriented, like I mentioned initially, integrated, used for management decision making. Okay, and all this data need to be reconciliated. And data reconciliation, okay, it has to be detailed, uh, and data has to be current, and this will enable decision making from management. Let's take a look at the slide. This is basically how they are constructed. We have customer database, sales database, and product database, which is centralized to data warehouse. Okay. And next we introduce ETL, extract, transform, and load. Okay, we go into detail. What are they? Extract, technically extracted from an OLTP database, transformed to match the data warehouse scheme loaded into the data warehouse. Okay. So let's take a look at typically, okay, as a process. Typically, data is transient, not normalized, which is uh, it's not customized. Restricted in scope, or you can do much to the data. Sometimes poor quality. Okay, after doing ETL, uh, it's detailed, okay, historical, normalized, comprehensive, enterprise-wide, uh, and timely, where data should be current enough to make decision making, okay, with full integrity. Here we have the process from operational system to enterprise-wide, where it's extracted, where data is captured. Okay, you see in the red circle here. Okay. So in extraction, okay, the extract step covers the data extraction from the source system and makes it accessible for further processing. Okay, the main objective of the extract step is to retrieve all the required data from the source system with a little resources as possible. Okay, logically the data can be extracted into ways before physically data extraction. Okay. In terms of extraction, we have local extraction, logical extraction, uh, which for example full extraction, which used when data needs to be extracted and loaded for the first time. Okay. Here the data from the source is extracted completely. Okay. This extraction reflects the current data available in the source system. Okay. This is the first initial extraction. And next we have incremental extraction. The changes in the source data need to be tracked since the last successful extraction. So as we progress, need to update, and there should be incremental extraction. And these changes in data will be extracted and then loaded. Okay. Any changes from the source data will have the last change timestamp. Okay. Also, a change table can be created in the source system. Right. Okay. Next, we have physical extraction, which is online extraction, extracted directly from the source system. Okay. The extraction process connect to the source system and extract the source data. So here the data is extracted directly from the source, okay, at the staging area. That's why it's called online extraction. Okay. In terms of offline extraction, okay, the data from the source system is dumped outside of the source system into a flat file. Okay. The flat file is used to extract the data. Okay. The flat file can be created by a routine process daily. Okay. Here the data is not extracted directly from the source, but instead is taken from another external area. Okay, and copies are made. So why data is extracted? So there should be a recovery phase, anomaly detection phase. Okay, if there's anything unusual to the data. Next we have extraction data discovery phase. Success of the data warehouse is the cleanliness and cohesiveness. Okay, data need to be customized or normalized to fit the requirement of the output, or for example the management, the bosses, the managers. Okay, and it needs to identify, examine the data source. Okay, right, from the data we are able to evaluate, okay, the output. Okay, we have data phase, data discovery phase, collecting and documenting of source system. It's one of the phases. You need to keep track of the source. Okay, make sure the data is correct, authenticated. Okay, point of origin of data I mentioned earlier. Okay, and also to prevent redundancy across duplication of the data. Okay, we do not want that. Next we have null values. For example, numbers that do not tie into anything. For example, one of the biggest risks when they are in a foreign key means the table is referencing from another table as a foreign key, and there's no data, and can lose a lot of data from there and create a lot of problems. Dates in non-date field. Okay, peculiar elements. Sometimes you will see data, different wrong type of data inside a field, for example. Okay, so next we move on. This is basic transformation, right? From extraction to transformation. Transformation converts data from the format of the source operation to the format enterprise. Okay, so some function, record, field level, more complex transformation. Okay. Next we have record function or field function. In terms of record level, we have data partitioning in selected areas, joining data, combining, okay, from other tables, for example, normalizing, okay, aggregation of data, you summarize it, okay. Field level function, you have single, one-to-one field or multiple field, okay, one to many or many to one. Okay. Here we have transformation. Technically, it's the main step where you ETL is added value. Okay. To the actual changes and guidance where data is being used, okay, for technically the output. Okay. And next we will move to the staging area. Okay. Take a look at the staging area. This figure here shows the staging area, the ETL process. Okay. As for the staging area, technically means that the data is simply dumped to the location called the staging area, so that it can be read by the next processing phase. Okay. The stage in use during ETL process is stored, okay, intermediate result of the processing. Okay. It makes it possible to restart at least some of the phases independently from the others. For example, if the transformation step fail, it should not be necessary to restart the extract step. Okay. Technically it's like a fail safe. And this should not be available to anybody, okay, because you do not want them to change the transformation. Next transformation, we take a look at the quality of the data. Okay. It has to be correct, should be clear, with quality and consistency and complete. Okay. So here data is checked and run in two places. After extraction and after cleaning and conforming, additional check are run at this point. Okay. Next we have the ETL processes, okay, where data is clean. Okay. Transformation data, cleaning data. At this stage, data are being clean, where they will detect any anomaly or anything unusual. For example, doing via data sampling. Okay, some of the column properties, enforcement, null value. Okay, you need to enforce it. Numeric value, high and low as a maximum, minimum. Long, short columns. Okay, and discrete values. So in terms of cleanliness, identify unique, okay, not available, or not or null value, for example. Okay, convert the phone number, zip code, standard form, and also validate the address field. Okay. Also we have misspell, error on dates, incorrect field usage, mismatch, address, missing data, duplicate data, and inconsistency. Right. Next, we have in order to clean it further, we have the diagram here shows is basically a yes no. So if the data is clean, you proceed. If not, okay, you load it. Okay. So transformation conforming, okay, is structure enforcement. Most definitely the primary and foreign key are very important. This is to ensure referential integrity. Okay. Um, Also to take note data rules and like business rules and logical data check. Here on the chart we see the load prior to the enterprise. So you need to ensure that the load is performed correctly, uploaded correctly. Um, any constraint or indexes should be disabled, and also ensure referential consistency. Okay. So types of load. Okay, first load entire dump, data dump, i.e. Putting whatever it has been extracted, okay, initially and into the enterprise. Incremental is data difference between the target and source at regular interval. Okay. So why incremental? Basically is to support large data set, greater amount of time. Okay. Usually uploading a huge amount of data would require large amounts of bandwidth, time, okay, and effort. So having said that, there is preserving history. Uh, Apparently, full load will not allow us to preserve historical data due to the size. Okay. So next we take a look at the comparison. Okay, on the left is full load and incremental load. Here we have truncated all rows and load from sketches, okay, as compared to incremental load, new record and update ones are loaded. Okay, not all, just the updated one. Requires more time for full load, less time for incremental. Full load also is easily guaranteed. Okay, there's nothing to worry. As for incremental, you need to do a bit of checking, um, just in case it's not loaded properly. Full load uh, can be lost, where the whole data could be overwrite, but then it's not all uploaded properly. Okay, and incremental load is retained. We still have the original data, but with the new changes. Here we have loading includes which dimension and facts. Can you take a look in detail? DSS, Decision Support System, viewed in relation to other data qualifying characteristic. Um, so in this case, DSS data is almost always viewed in relation to other data. The data can be alone and it has to be supported by other tables. And this is where it's stored in a dimension table. Okay. Some facts, numerical measurement values represent a specific business aspect or activity. Okay. Stored in a fact table at the center of the star scheme, for example. Okay. We have the primary key and then the foreign key. So contain fact that link through their dimension. Okay. And it can be computed or derived at runtime. Okay. So last but not least, is updated periodically with data from operational. Okay. As the progresses, data are being updated. And we have here overall view of the whole data warehouse. Okay, on the left we have the source system, where it's being extracted. It could be internal or external. Okay, that's where the extraction is E. Okay, and then we have the data staging stage, where data is storage, for example, where it's transformed. Okay, process, clean, reconcile, derive, match, combine, remove, do. Okay, transform. Oops, sorry about it. Okay, and next will be uploaded. Okay, from the data house to transform layer and to the data mart. Okay, where the end user here are able to view the, to run queries, okay, to write reports. Okay, and it also could be connected to CRM, or customer relationship management. Okay, so that is the process for ETL. So any question? So that's pretty much it. If you have any question, please feel free to email me, or just set up an appointment. I'm be willing to meet you guys. Alright, stay safe and thank you very much. Goodbye.